All right, so welcome to this particular video where we'll be looking at tutorial sheet 7, P191. So without wasting much time, let's start with question 1. And part A is saying a horizontal force is used to pull a 5.0 kilogram cut at a constant speed of 5.0 meters per second across the floor, as shown in the diagram below. If the coefficient of friction between the cut and the floor is 0.50, calculate the magnitude of the horizontal force along the handle of the cut. The gravity is equal to 9.80 meters per second squared. So there are some points that you really have to take away before you even start making your calculations. And one of them is that this cut is moving at a constant speed. And if it's moving at a constant speed, that means acceleration is equal to 0. There is no acceleration on this particular object, which means the forces are balanced in the axis where you have your motion, which means if we want to draw a free body diagram, we are going to have the weight of this object pointing down, mg. Then we have the horizontal force, which is pulling this object. I'll call this the force F. Call it just F. Then there's a frictional force. Since they've given us the coefficient of friction, there's a frictional force, which is pointing in the opposite direction of motion. Then there's a normal force, Fn. There's a normal force like that. So these are the forces that are acting on this particular object. Our job is to calculate the magnitude of the force that is pulling this particular object. And I've said, since they've said the speed of this particular cut is constant, that means there's no acceleration, which means I'm going to say summation of forces in the x-axis where there is our motion should be equal to 0, meaning F, which is the force pulling the object, minus the force of friction. This should give us 0, meaning the force that is pulling this particular object will be equal to what? Will be equal to the frictional force, like that. So in simple terms, we can just plug in the friction here. It is going to give us the force that is being used to pull this cut horizontally forward. So I'll say my F is equal to the formula for calculating friction, which is mu k, since this one is moving, mu k multiplied by the normal force, Fn, like that. And if we look at the forces that are in the vertical axis, we are going to notice that there's no acceleration in the vertical axis, which means the forces are at equilibrium. That means Fn is directly equal to mg. So I'll say my F is equal to mu k multiplied by mg. And that, ladies and gentlemen, will give us F being equal to mu, which is 0.5, multiplied by mg, the mass, which is 5, multiplied by gravity, which is 9.8. And this is going to give us F, the force here, which will be equal to, let me just plug this in to my calculator. My F is equal to 0.5 multiplied by 5.0 multiplied by 9.8. Okay, the force that is used to pull the cart forward is equal to 24.5 newtons. 24.5 newtons is the force that is used to pull this particular cart forward, given the condition that have been given in this particular scenario. And that is all about question 4. I mean question 1A. Can move on to the next one, which is question 1B. Question 1B, they've told us to say, in the figure below, a boy is dragging a box of mass 8.0 kilograms attached to a string. The box is moving horizontally with an acceleration of 2.0 meters per second squared. If the frictional force is 12 newtons, calculate the applied force F at an angle theta is equal to 60 degrees. So we are supposed to calculate the force F here. And based on the data that we've been given, I'm sure you're going to notice, just put this in a brighter color. Let's use blue. We're going to notice to say there's a force of friction that is pointing in that particular direction of 12 newtons. Then there's this force which is pulling the box forward. And this force is applied at an angle, which means it is existing in two axes, in the vertical axis and also the horizontal axis. So the component which is in the vertical axis, this acceleration is in the vertical axis, is the one which is doing the work here. So I'm going to have this, the one which is in the x is the one which is adjacent to the 60 degrees that we've been given. It is going to carry a cos. So this will be F cos theta, but there will be another one also in the vertical axis, which will be F sine theta, whilst there will also be a normal force there, then there will be mg, like that. So these are the forces that are acting on this particular object, and our goal is to find the force F that is being applied at an angle theta. So first things first, we can say summation of forces in the x-axis is equal to mass multiplied by acceleration. The summation of forces, we have how many forces in the x-axis? We have this particular force, which is doing the work, and we have a frictional force here. So I'm going to say F cos theta minus friction should be equal to mass multiplied by acceleration. So our F cos 60 degrees minus the force of friction, which is 12 newtons. This should be equal to mass multiplied by acceleration. The mass of this particular block is 8.0 kilograms. Then there's the acceleration, which has been given to be 2 newtons. So F cos 60 minus 12 will be equal to 16. So I can take 12 to the other side of the equation. I'm going to remain with the F cos 60 being equal to 16 plus 12. This is going to give us a value of 28. 28, meaning F will be equal to 28 divided by cos 60. And therefore, ladies and gentlemen, our F will be equal to 56 newtons. That means the force F that is being used to drag this box forward, applied at an angle of 60 degrees, is basically equal to 56 newtons. 56 newtons, and that is all. We can now move on to the next question, which is question 2. We are done with both part A and B of question 1. Let's go to question 2. And question 2, part A is saying two boxes are connected by a lightweight string, or two boxes connected by a lightweight string are resting on a smooth table, each with a mass of 12 kilograms and 10 kilograms respectively, as shown in the figure. A 40 Newton force is applied on one end. Determine 1, the acceleration of each box, and 2, the tension in the string connecting the boxes. Determine the acceleration of each box and determine the tension in the string of each um, box. So this is another question which is very simple. It looks threatening, but it's very simple, because if I try and draw the forces that are applying on each of these two boxes, we're going to say we have this particular force that is being applied to pull this ball, or this first box, which has a mass of 10 kilogram. Then there is the weight of this particular box, mg. There's the weight of this particular box acting downwards, mg. There is normal force. There's also normal force there. Then they've said this surface is smooth, which means there is no friction. There's no friction. So these are the two boxes, ladies and gentlemen. So what are we going to do? If you pull one box with a particular force, the acceleration of these two boxes will be the same, which means they are sharing the same acceleration. And the tension in this string that is connecting the box is also going to be the same, which means they are also sharing the same tension. So we can draw these free body diagrams individually. Say this is question 2. Question 2, we have one box here which has this force mg. Then there is tension. This tension is pointing forward since it's causing acceleration. Then there is a normal force there. And this is the 12 kilogram box, the one which is behind. Then there is this other one which is in front. This is acceleration, so the tension in the string will be pointing behind where the other box is. There's also mg here. Then there's the applied force here, F. Then there's also the normal force, like that. So on each box, we're going to say the summation of forces on this 10 kilogram box, summation of forces in the X will be equal to what? Will be equal to mass multiplied by acceleration, like this. Summation of forces, we have this force which is causing, or which is in the direction of motion. Then there's the tension which is pointing in the opposite direction as to the direction of motion. So which means the tension here will act as a negative force. So we're going to say F minus T will be equal to mass multiplied by acceleration, like this. The applied force minus tension will be equal to mass multiplied by acceleration. Which mass are we talking about? It's the 10 kilogram mass that we have there. The 10 kilogram mass that we have there, and we can plug it in just to simplify things. So I can say F is equal to, or F minus T, sorry. F minus T will be equal to 10 multiplied by acceleration, 10a. Then let's look at the 12 kilogram box. We'll say summation of forces in the x. This will also be equal to mass multiplied by acceleration. But if you look at the forces that are in the x-axis on the 12 kilogram box, we just have one force, which is the tension. And this is the force that will be causing this object to accelerate forward. So it is a positive force. So it is the only force in the x-axis. We're going to say tension is equal to mass multiplied by acceleration. What mass are we talking about? It's 12. TA, so which means the tension is equal to TA. And if we look at the two equations that I have, I can call this my equation 2, or still I can call this my equation 1. Like that. If we look at these two equations, you can tell to say they are missing the same things. They are missing tension and they are missing acceleration. So I can get this and plug it where I have tension in this other equation to help me calculate the value of acceleration. So I'm going to say F minus, what do I have here? Minus 12A. 12A, this will be equal to 10A. I'll say force minus 12A is equal to 10A. Okay, so the force will be equal to 10A plus 12A. The force will be equal to 22A. Okay, can say the force there is equal to 22A. Okay, so did they give us the acceleration? Let me just check the question again. Okay, we are looking for the acceleration of each box. Sorry, we are looking for the acceleration of each box, and we have been given the force that is applied. They've given us to say the force that is applied is 40 newtons. So we'll say 40 is equal to 22A. Divide both sides by 22, even this side by 22. Our acceleration will be equal to 40 divided by 22. 40 divided by 22. This is 1.81. So acceleration is equal to 1.81. Why am I writing it like this anyways? Acceleration will be equal to 1.81 meters per second squared. Acceleration is equal to 1.81 meters per second squared. And we can get this value of acceleration now and plug it here to find the tension. We can get the value of acceleration that we've calculated to find the tension that is in the string. So I'll say this was part 1. Let's go to part 2. Tension will be equal to 12A. And what is our A? 1.81. That multiplied by 12, our tension in the string is equal to 21.81 newtons. So the tension that we are having in the string is 21.81 newtons. And that means we're done with question A or question 2A. That means